Hi everyone, my name is Sarah. I'm a third year PhD student in Olga Vitek's lab. And as Kylie said, today I'm going to talk about R Markdown first and then Git and Github. So we have a short introduction about R Markdown. I give you some intuitions about why it's a good idea to use R Markdown, and then we will move to Git and have some hands-on experience working on a demo and Git together. So Markdown was a text to HTML conversion tool which was designed for web writers. It was easy to use, easy to read, and it converts text to HTML format. And R Markdown is just a flavor of Markdown. So it's basically the same thing, but the difference is that the output of R Markdown can be PDF and MS Words other than HTML. And the cool thing about R Markdown is that you can actually embed R codes in your R Markdown. And then when you run it, the output actually contains your code, which is active, such that if you change part of the code, let's say the data set changes, then all the figures, all the results of the equations that you are using from that data is going to change. So if you're writing a report, then if you just manually add the results and the plots and then something changes in the data, you have to rewrite everything from the beginning. But if you use R Markdown and if you change some part of the code, like the data, then everything will change it automatically in R Markdown. So everything is reproducible in R Markdown. Now I'll go ahead and create an R Markdown file for you, and I'll show you some examples of how we can work with that. And the whole slides is available on Google Drive. You can download it now or later, and all the steps of whatever I'm doing now is actually there in these slides. Okay, so for creating an R Markdown file, you have to open RStudio and click on this small plus button all the way up left and choose R Markdown. So it will ask you to give a title to your document. I'll assume that I'm going to produce a report, so I'll call it my report. And then the author is Sarah. The default output format for R Markdown is HTML, but you can select PDF or Word as well. But if you're going to select PDF, you have to install Tech. For Mac, it's called MacTeX. For Windows, it's called MikTeX. And then for Words, you need to have Word installed on your system. I'm going to select HTML for now. If you see, we have other options as well here. Here is a presentation mode where you can create presentations using R Markdown. And here is a cool thing about creating shiny presentations with R Markdown that I'm going to show you a template of that at the end of this talk. So let's go ahead and create our HTML document. So R will create a template R Markdown for us. It has the title is my report, and here is the section which is called R Markdown, where you can show by these signs. And then here it includes some codes and some plots. And now I'll go ahead and run this for you. So in order to run that, you have to click on this neat button all the way up. it will ask you to save it. I'll ask it on desktop, call it my report. And here's the result of the template R Markdown. You can include URLs there. And the cool thing is that you can include your R codes, such as here we have the summary of cars dataset. And we can also see that this is the output of running this part of code. And here we have some plots. So how can we create R chunks? These are called R chunks, where you write your codes there. So in order to do that, you have to click on code and select insert chunk. And then it will create an R chunk for you, where you can write basically all the code that you want to generate in your report. And here we have a template, so I'll just delete that. So we have an R chunk, which I put which we have the code for the summary of cars there. And here is some cool things that we can do with this. So imagine that you want to write part of the code in your report that you do not want to include the code in the output. And you also doesn't want to include the result of the code in your output document. Let's say, for example, if you want to call a library, like a library of ggplot2, and you're not interested in for your boss to actually see this stuff. You're actually interested to just show the plots and all the results, and you do not want to include that in your output. So what you can do is to add the option called include to this R chunk and set it to false. If you do that, the R Markdown will still run ggplot2, and it will understand that. And if you use ggplot2 in the rest of your R chunks, like here or here, there's no problem. But the library of ggplot2 will not appear in the screen once I run this document. So if I go ahead and run that, you'll see that we do not see library of ggplot2 there, but it's actually working behind the scene. Another thing is the option called echo equal to false. Let's say that you want to generate a plot and you are interested to show the result of this plot, but you don't want to include the code in your report. So all you have to do is to just type echo equal to false, just like this, and then whatever you write as the code in this R chunk will not appear in your output document, but the result will appear. So here, if I need that again, you will see that the plot appears here, but the code which states the plot of pressure, which is the name of this plot, does not appear over there. Versus if I delete that and run it again, I'll see the code together with the plot. And the last thing is when you want to write some sort of report where you're interested in just showing the code, not the result of the code. This happens when you're writing a blog where you are describing some sort of code, but you do not want to include the results in the output. So all you have to do is to add an option called results and set it to hide, which means that we want to hide the results. So then in the output, you will see the code, which is summary of cars, but you will not see the output of that. Which is here. You see the code, but no results. And then the last thing is,
A question.
yes.
My understanding at this point is that include equals false and echo equals false are synonyms for each other.
Echo equal false and include equal false.
Both of them run the code but do not send the output to the report.
No. So the echo equal to false just doesn't show the code, but it shows the output. So like, for example, here for...
Okay, so include equals false if it throws, like, for instance, like some library statements throw out some information about loading the library.
Exactly.
That's where you have it.
Exactly.
Okay.
Any more questions? And you can also change the dimension of your plots. You can set fig.width equal to something like 4, fig.height equal to 4, for example, and you can also add captions to the plot. So if we run that, we have a plot smaller than the previous one because I set the height and width to 4, and also it has a caption as here, my caption. So there are a lot of other options where you can use in your R chunks to change the designs and the codes. I have provided some references for you to go and look more into those options. And now I like to show you how to create interactive presentations with Shiny, which I just did it today after listening to Vincent talk. I thought that it would be cool to show you this kind of presentations. So here, if I choose the Shiny mode of the presentation, and let me give it some title, and choose the Shiny presentation mode and create one presentation. Oh, this machine does not have Shiny installed. So let's give it a moment. No, I just decided to do it today after listening to Vincent talk. That's why. Okay. There we go. So here we have a template presentation with Shiny, which, okay, how can I go to the next slide? Okay. So here's the cool thing about it. So you can create presentations with Shiny, which is interactive. Now we have a plot in the presentation that is a histogram, and you can actually change the number of the beans in front of the audience, like this, and the plot changes, which is cool. And you can also change the bandwidth adjustments in this plot. So if you're interested, you can go and learn Shiny and create interactive presentations with Shiny. So that was just a motivation.
How did you start that?
I clicked on this plus, and then R Markdown, and then I chose Shiny,
Right.
and then Shiny presentation.
Oh, okay, as opposed to that.
Yep. Okay, any questions so far? Mm-hmm.
I have a question.
Yep.
Can you show us how we would render an R Markdown document if we aren't using Shiny?
If you aren't using Shiny?
I mean, if you aren't using RStudio, excuse me.
Oh. Can you say it again?
So if I want to take the .rmd R Markdown document and turn it into a HTML or PDF, and I'm not using RStudio, how do I do that?
I don't know.
Can I?
Sure.
I also just want to make sure we know how to output one of these if for some reason you aren't using RStudio, or if you're doing this from the command line or something. Let's see, let's find where your RMD file is.
Okay.
So the first task is to find where we saved the RMD file.
So it's here. Oh, okay. Like that, right?
Okay.
Do you want the .rmd? No, you don't want that.
All right, so this is our file, the file name for our R Markdown document.
Mm-hmm.
Okay, so we can use the render function from the R Markdown package to do the same thing that the knit button does. Let me go back to the report. So normally, if we're using RStudio, we can just hit the knit button. If we are not, and we just want to do this using a function, we can use the render function from R Markdown. Because I don't know if we actually have R Markdown loaded right now, I can use this double colon notation to refer to I'm using this function render from this package R Markdown. And if I just do that, it'll run through the same thing that hitting the knit button would do. So that's just a useful way to convert from R Markdown, output that to the HTML or the PDF without having to go through the GUI if for some reason you're using this just from the command line.
Thank you.
Carry on.
Getting back to my original question, even if I specify that it slides, I still don't know how to run it.
You still cannot run it?
Right. Because if I try run presentation or run, then it's asking for more information.
Yeah, Kyle is gonna take a look. Okay, next subject is Git and Github. So before we go on, how many of you are using Git and Github? Okay, half of the class. So I'm going to give you some, again, motivations of why we like to use Git and Github. So here is a cartoon from PhDcomics.com, which is a website that shows the life of PhD students. It's very fun to look at the cartoons. Here is one part of our life where we want to write a report or write a paper, and we think that we're done. But then we go to the advisor, and he says that, no, you have to make these changes, these revisions to the file. So you will make the changes, and you may rename the file something else, like final revision 2. Then the same thing happens. You rename the file final really this time. And then happens again and again. And as you can see, you'll end up with a really silly name at the end, where why did I come to grad school is the final file name. What can go wrong? Even if you are successful and finally your advisor approves with your file, then 1 year later, if you open up your folder and look at your files, you cannot remember which file was the actual final version of the paper. You may get lost. You cannot follow the trends of the improvements that you made to the paper that leads to the final version. One possible solution is to name the files wisely. So name them final, final 1, final 2, all the way to the end, so that you can track the improvements. But the disadvantage is that, so first of all, it stores a lot of disk space from you. And the second disadvantage is that you cannot keep track of the changes. You cannot easily follow what exact changes you made to the file. So what is the difference between final 2 to final 1? You have to manually dig into that and look for the changes. The other situation is that let's assume that your project is now in a good state, and then you suddenly decide to make some huge changes to the project, and you'll start do that, and after some time, the project gets really messy, and you'll receive a lot of errors where you don't know where the source of errors are, and you have no idea what is wrong with the project. And you wish you could go back to the previous version where everything was fine, but you cannot hit Control-Z 100 times to go back to that version. So, and again, a possible solution is to always keep a copy of your good state project, but again, you don't know when you're going to mess things up, so you don't know when to make that copy. And then the other disadvantage is that, again, it occupies a lot of your disk space. And the third situation is the most important one, when you are working with someone together in a team and on the same project. So you make some changes to the project, and then you notify your teammate that, hey, I did these changes. And then your teammate may make some changes and notify you, and then you have to go back and forth, notify each other of the changes that you made to the project, and then you have to manually look into the project and adjust the changes, which is really frustrating. And as the subject of our talk is Git and Github, the solution for all of these problems is using Git and Github. So I'm going to introduce these concepts, Git, version control, repository, commits, and GitHub in the following slides. Git is a software that you install locally on your computer, and you can handle version control of your files easily. So version control means to take a snapshot of your files every time you edit them. So basically, you freeze your project, and you take a snapshot, and then you go on and make changes. That is called version controlling. And it has some advantages, where you can automatically track changes that is made to your documents and projects. You can keep a history log of all major and minor changes. It allows you to revert to earlier versions, which is really cool. So if you mess up, you can revert to the earlier version easily. And then you can compare different versions of your files together. So you can basically look at exactly the places that the changes were occur in your files from the previous version to the current version. And then most importantly, you can share and sync projects between people. And a repository is when you start a Git project on your computer, you're going to store the history, the entire history of the project locally on your computer. And the storage of the project and its history is called a repository. So that is a local repository on your local computer. And we also have a remote repository where I'm going to talk about it later. And commit. So every time you make some changes and you save your work, you can commit your changes to Git. Basically, write a message telling Git that, OK, I added this plot, I made these changes, and then you commit your message to Git. So then when you commit your changes, every time you make changes to the project, these commits make a graph. So just imagine a graph which has a lot of nodes, and each of those nodes is one of your commits, where you put a message for each of them, and then by looking at the messages, you can remember what was the change that you did at that point of time to the project. And when you want to decide to revert to a version of the project, you can basically read the commits messages and then decide where you want to revert. OK, yeah, I said that. And here is the definition of GitHub. So all I talked till now was locally on your computers. Now GitHub is an online service that hosts Git repositories for free. So you can create Git repositories on your local computer and then make a copy of that to GitHub, which is a server that can host all the GitHub repositories from all the users. So you can save your projects, all the history of changes that Git has made for you in the local history. And then once you commit changes to your local repository, you can push them to GitHub. So this is so here is I'm now telling about the new definition, which is push. And I'll tell you about it later. But push means to basically push the changes from your local repository to the GitHub server. And the advantages is that if something happens to your computer, you will not lose your data, because everything is stored on GitHub. And then it also lets you to work with a team easily, because all the team members are going to push their changes to GitHub, and then you're going to pull those changes back to your local repositories. So here is kind of a recap of what I said. So the working directory is the actual directory on your computer where you're working. The staging area, I didn't talk about that, is a set of files in your working directory that you have changed since your last commit. And then the local repository I just explained is a version of Git repository on your own computer, and the remote repository is what we refer to as GitHub. Do you have any questions? OK. Here's a picture that describes everything clearly. So assume that this is you. This is your computer. You write codes here. You commit them. And then you can push them to the GitHub server. And then again and again, you make changes to your code, push them to GitHub, again, push them to GitHub. But our teammate, let's say this one, this guy also makes changes to the project. So this guy makes changes to the project, commit them to his own local repository, and then push them to GitHub. And then when you are working with a team, you have to push and pull together. So you have to pull first from GitHub to update your files to the latest updates that your teammate put on GitHub, and then make your own changes, commit them, push them to GitHub, and then your teammate has to pull the changes first, update his own repository from the latest changes that you pushed, and then make some changes by himself, and then push them to GitHub. And this process goes on and on during the project time.
Are there any controls that to avoid the problem where both you and the other person are making changes simultaneously?
No, in these cases, a conflict may happen, and then you have to solve the conflict. I'll show you a small example of conflict later in this lecture. But yeah, that happens.
Git tries to be smart. So if you edit a different part of the same file, it will be fine. It's only if you edit the same part of the same file, then you get the conflict which happens.
Okay, so it tries to do a smart sync in some sort of sense.
And it's pretty good about it. Much better than earlier.
Yeah, I mean, my experience is the database locking kind of situation.
There are certain protocols you can follow to try to avoid conflicts as much as possible, which we'll talk about.
Okay, so now I want to. Okay, so first, before I do the demo, so if you want to check if Git is installed on your system or not, you can open terminal on Mac and command prompt, I guess, on Windows, and type Git there. If you receive an error, it means that Git is not installed. And then you should go ahead and install Git from either of these links, depending on your system. Okay, now I will show you how we can register for a GitHub account, and then I'll create a repository, and we practice everything that I told you during the rest of the lecture. Okay. So we will go to github.com. If you don't have an account already, you can sign up. I have an account, so I'll go ahead and sign in. Okay, here is the GitHub environment. You can see that I have some repositories already there. And in order to make a new repository, you have to click on this new button here in front of repositories. And then let's give it a name. Okay. I'll name it my first Git try, and I choose a public repository where everybody can see the repository because like it's a public account. But if you want to have a private repository and your project is sensitive, or you just don't want everybody to see, I guess you have to pay some amount of money in order to be able to create private repositories. And then I'll initialize my repository with a README, which is a text note where I can describe the project and put some notes, maybe for my colleagues to look at. And then I click on Create Repository. OK, so the repository is created. And we want to go ahead and clone that into our own computer. So I'll copy the link. And then I'll open a terminal. Before starting to clone the project, we have to introduce ourselves to Git. Tell the Git on my computer that, OK, this GitHub account is for me, and you have to link to that GitHub account. So you have to tell Git that, OK, these are the commands that you have to write, username, and then you write your username. Mine is SR Taheri. And then you hit enter. And then you have to tell your email address as well. Like this, user email, my email. OK, now Git knows me and my username and my email. Now I can go ahead and clone my repository. Is there anyone who is not familiar with working with terminal or the command prompt? Or everybody has done that before? OK. So let's see what is the current directory. I want to create the repository on desktop. So I'll go to desktop. OK. So in order to clone the repository, you have to type git clone and then paste the URL that I just copied from GitHub here, and then hit enter. OK, so now let's see. It's here. It's cloned this my first Git try from GitHub to my own system. So now let's create a project in RStudio and then write some codes there and practice committing and pushing and pulling and all the things that we just learned.
Sorry, can you just go back to
The command, sure. And everything that I'm writing is on the slides, so don't worry about that. OK, are you done? OK, so I create an R script. I'll save it in my first Git try where my repository is, and I'll name it my project. Now, write some codes there. So the data is the iris data, and then I want to plot x equal to iris sepal length versus y equal to iris sepal width. So I created a scatter plot of the iris data set for the sepal length and sepal width. So I'll save that by clicking on Command S. And then I'll go to the directory where my file is, which is my first git try. So I'll change the directory to where my repository is located. And then I type git status to basically see the status of the Git repository. So it tells me that you are on branch master, which is the only branch that I'm working at. I'll talk about branches in a few slides. And then it tells me that you have some untracked files there in the my project that I just created. And I have some changes in my project that I have not committed them yet. So what I should do is I should add the changes to the staging area and then commit them to Git. So I can do that by typing git add. So what is it that we want to add to Git? It's this file. So I can write the name of this file, git add my project .r. So if I type git status again, it will now show that file in green, which means that now that file has been added to the staging area. Now I can go ahead and commit a message to Git, which I can do it by typing git commit -m, which is an abbreviation for message, and then inside these quotations, I can write my commit message. So I'll write scatter plot of sepal length versus sepal width, which is what I just added to the file. And then hit enter. Oh yes, thanks.
Give an extra parentheses.
Oh, extra parentheses. Yep, thank you. Okay, now I have committed my message successfully to Git. And the next step is to push the changes to GitHub. So for pushing, I have to write the command git push origin, which is the name of the remote. And the name of the remote that I'm working with is always origin in that case, unless you're working with someone else's remote where you have to write the name of the remote of that person. But for now, we are working on our local repository and pushing to our own GitHub. So the name of our remote is just origin. So you'll type git push origin. And which branch are we in? We are on branch master. So we have to tell Git to push it through branch master. So that's the whole command, git push origin master. And it's done. So now if you go ahead here on your GitHub website, and then if I refresh it, you see that my project.r successfully pushed to GitHub, and then my comment is also here. Okay, what else? Let's assume that we now have a collaborator which pushes something to GitHub, and then we want to pull that back into our local repository. So I'll play the role of the imaginary teammate. So I'll go to the GitHub and manually make some changes to the README file, and then I'll pull those changes back to the local repository. So I'll edit this file. I'll add a message here that I am happy to learn Git. Okay. Then I'll commit the changes. Now this change that has been made to README is here on GitHub. Assume that your teammate has pushed that change to GitHub, but you still don't have that on your local repository. So now what I can do is that I should pull all the changes from GitHub to my local repository. The command is the same as pushing, but you have to change push to pull. That's all the changes. So you'll write git pull origin master. And now, if I go to my README file, I'm happy to learn Git appears. So you successfully pulled the changes from GitHub. Okay, so that is the typically workflow of Git and GitHub. You make changes, you add those changes to the staging area, you commit the changes, push the changes to GitHub, and then if you have a teammate, you have to also do the work of pulling the changes to your local Git repository. Now, I want to talk about situations where a conflict may happen, as you asked. So now let's assume that, again, my imaginary teammate make some changes to the R file and adds a histogram here. X is equal to this thing. And we will, okay, and the teammate writes some commits as well, which is add histogram of sepal length and commit the changes. Okay, now you don't know about that. You are working on your own version of the project. So what you do is that you will go here and you'll say that, okay, I want to add another scatter plot of iris, this time petal length and width. Okay, like that. And then you save the changes. And then you open up your terminal. You will type git status. It shows you that, okay, you have modified my project.r file. So now you will go ahead and add that to the staging area by typing git add. And here is another way to add files to your staging area. So one thing that you can do is to just type the name of whatever you want to add to the staging area like that. Or just, my project.r. So this is one way, but if you have multiple changes to add to your GitHub, you don't want to add them one by one. Let's assume that you have like 20 changes in different files. So what you can do is, instead of typing the name of each of the files manually, just write -- all. So it will grab all the changes and add them to the staging area. Okay, so if I write git status again, it successfully added my project.r to the staging area. Now I can go ahead and commit my changes, write a message, which is the scatter plot of petal length versus petal width. Okay, now I have successfully committed my changes to my local Git repository, and now I want to push the changes to GitHub. And let's see what happens. We receive an error. And why is that? That's because my teammate has already pushed some code in the same project at the very same place that I just added that line of code. And now GitHub is confused, doesn't know whether to accept my code, my friend's code, both of them. What should it do? So it suggests hint is to git pull first before pushing again. And I'm going to do that. So I'm going to pull. And it says that, hey, we have conflicts. Merge conflicts in my project.r. And we have to solve the conflicts. If you go back to the actual file, we see that, oh, we have conflicts. And always the conflicts appear between those two lines. One is with, I don't know what to call those, smaller signs, I don't know, with a head, and then this one with this long sequence of numbers. And then you'll see some equal signs at the middle of that, and your own code is on top half above the equal signs, and your teammate code is below those equal signs. So the plot is what you actually added to the file, and the histogram is what your friend adds to the file. So now you have to solve the conflict. So what you should do is to, okay, look at the code, and based on the project, decide whether you want to keep both of them, one of them, or none of them, or whatever. The choice is yours. So before doing anything else, just remove those signs. And I decide that I want both the scatter plot and the histogram together in the project. So I'll just keep both of them like that. So now I have solved the conflict, and then I have to go ahead and save the file, Control S, and then go to terminal and see. Now if I type git status, it says that my project.r has been modified. I'm going to add these modifications to the staging area by typing git add -- all, and then commit the changes. So basically, I'll say that I have solved the conflicts. So I'll write that solved conflicts. And then I push that to GitHub. Okay. Now if we go back here, we will see that now both of the codes appear in GitHub and the conflict is solved. Okay. Okay.
Does the start sync only apply if you've made changes to the same
Okay, this is all that we practiced, and it's available in the presentation slides. The next topic is Git branches. So up to now, we only have one branches, and that branch was the master branch, where it was the main branch that I and my teammate both worked at the same branch. But now, assume that you want to make big changes to the code without messing up with the mainstream of the development. You have some ideas in mind, you want to develop them, but you don't want to mess with whatever is going on the master branch of the code. So you will create a separate branch, the green one here, and then this branch is basically the same project as it was here, but at this point of time, you will start modify it based on your own thoughts, based on your own ideas, and make your own branch, make some modifications to the project. And whenever you feel like that, okay, you're ready to merge the changes to the mainstream of the project, you will merge the changes to the mainstream of the project. So note that while you are working on the project, other team members may also work on the main stream of the project, which is the master. And then once you are done with your own branch, you'll have to find a way to merge all those changes together so that everybody can then follow from the master branch. So here are some useful commands for working with branches, and I'll again make a small demo to show that. Git checkout -b, name of the new branch, will create a new branch for you. Git checkout, name of the branch, will switch between branches. So if you create a branch named branch1 here, then if you type git checkout branch1, you will go to branch1. If you type git checkout master, you'll switch to branch master. So this way you can switch between branches easily. And if you type git branch, it will give you a list of all available branches in the project. And then here is how you can push the changes from one of the branches. Actually, you don't need to put that part. You can just push it just as we did it before. Git push origin branch1, for example. And then finally, when you're done with all the changes in the branch, you'll use this command, git merge, to merge your branch with the master branch. And then you can delete your branch with this command, git branch -d. Now just continue with the same project and create a branch for you. Okay. So I'll create a branch typing git checkout -b and name of the branch, which is branch1, for example. So now we have switched to a new branch called branch1. Let's see the list of available branches by typing git branch. Okay, we have two branches, branch1 and branch master, and we are on branch1 because branch1 is in green. So now we are in branch1, and we can make changes to the project. Okay, let's go back to RStudio. Let's say that I want to add a complex function, which is a function that takes some input and it prints something like we are doing complex things here. And then you save it. And now everything is the same as before. We are now in branch 1, so you can go ahead and see the status of your branch, which is that, okay, we have modified this file. Just like before, we will add the changes to the staging area. Then we will commit our changes on branch 1, which is add a complex function. So we commit that, and then we push that. Git push origin. This time it's not origin master, it's origin branch 1. So, okay. So let's see that here. So now, now we have 2 branches. Branch 1 was just created less than a minute ago. On GitHub, we are on branch master. So if we go ahead and look inside my project, you'll not see the complex function that I just wrote. But if you switch branches to branch 1, and then go to my project, you'll see that that function actually is there. So we can do work on branch 1 as much as we like. We can make another complex function like this, save it, then git add all, git commit -m second complex function, and then git push branch 1 to push the changes. Git push origin branch 1. And now that we are on branch 1, second complex function is also there. So now let's assume that we are now ready to merge our changes to the master branch. What we can do is that, okay, first of all, we have to switch to branch master. And we can switch to that by typing git checkout and the name of the branch, which is master. So git checkout master, you have switched to branch master now. And now we want to merge our changes to branch master. So we will write git merge branch 1. So this command will actually merge branch 1 with the branch that we are already in, which is the branch master. Okay, cool. So now branch master is now updated, and all the code is also in branch master. So now that we have merged everything to branch master successfully, we don't need branch 1 anymore, so we can delete that. We can delete that by typing git branch -d branch 1. And now branch 1 is deleted. Okay, I think I have to now push the changes. Git status. git push origin master. Okay. I don't know why branch 1 is still here.
You deleted it locally.
I deleted here, but it's not deleted on GitHub.
Right. So I don't remember the syntax off the top of my head, but you have to delete it in origin.
In what?
Right, in origin. So origin is the Git repository that lives in a GitHub, right?
Mm-hmm.
Pushing to. And so anything you do locally that doesn't talk to origin is not going to affect it.
Yeah, but I called git push origin master at the end to tell GitHub that I did.
Right, but push master only pushes to master. It won't ever affect any other branch. Right? So git push without any other arguments may delete the upstream branch, but honestly,
Maybe let's try git like that. Maybe.
yeah. So
It didn't.
I'm not sure if there's a way to do it remotely. You have to do it on GitHub.
it's git push origin dash delete and then the name of the branch.
Git push dash
Two hyphens delete and then the name of the branch you want to delete.
like D or delete. Delete and then branch 1.
Origin after push.
Yeah.
Okay. Okay, now it's deleted. Yeah. Thanks. Okay, any questions on branches? So the last topic is fork. Okay, so people are writing repositories all over the world, and you might want to use their repositories into your own work. So what you can do is that you can fork someone's repository into your own GitHub account, and also you can clone that as your local Git repository. The reason that you want to do that is that you want to either make changes to someone else's code to make it better, improve it, or to use it for your own purposes. That's the reason that we might want to use a fork. So here I'm using all the slides from these slides is from this website, which they actually create a repository for people to fork from. So we are going ahead and fork a repository into our GitHub and then clone that into our own Git repository. Okay, so I don't have, maybe I can click on this, yes. Okay, here we go. So here's the GitHub account of somebody else called Octocat, and there they have created a repository called Spoon Knife, and we are interested in the repository, and we want to fork that and have that repository into our own GitHub, and then later clone that into our own Git repository to modify that and make some changes. And sometimes people do that because they find a bug in somebody else's code, and they want to fork that, and then they want to solve the bug. And then once they do that, they pull requests to the owner of this GitHub repository, and they ask them to consider these changes into their own repository, and they may accept or they may not. So here we will go ahead and fork this repository. So here is a small fork tab here that I'm going to click on. It will ask where should we fork it. I want to fork it into my own GitHub account. So I'll select myself, and it will fork this Octocat Spoon Knife into my repository. So now here I'm actually in my own GitHub account. As you can see, here is my name and the repository that I just forked. So now it's just like that I created this repository from scratch by myself. Everything is the same as what we started at the beginning of the session. Now you can go ahead and clone that, copy the URL, and clone that into your own Git repository on your computer. So I'll select a location. So now I'm on desktop, so I want to clone that into the desktop. So I'll go ahead and type git clone, and I'll paste the URL of that Spoon Knife repository. And as you can see, it has my name there. So it's github.com/Taheri, which is my username, and then the name of the repository. So you have to just deal with it as a normal repository in your GitHub account. So now I'll go ahead and clone that, and you can see that the Spoon Knife repository is here on the desktop. So then you just deal with it as an actual repository of your own. You make changes to it, you commit the changes and push them to your own GitHub account, and everything is the same as before. There are some more things that you can do with fork, but I thought that we don't have enough time, so I didn't include those into the slides for today, but I included a link here where you can go and read the rest of the things that you can do with fork. And basically it's changing the files and then request a pull request to the owner of the repository to accept your changes there. So I want to ask you to practice these steps, and I'll be here till 5 or 5:30. I'm here till 5:30, so I can answer any questions if you have, and then practice fork as well because you're gonna need it for Kylie's session. So, and here are some useful resources where you can use.